All right, so once you've prepared the BI reports and dashboards, and the executives have extracted insights about the business, what do you do with the information? You use it to predict some future values as accurately as possible. That's why, at this stage, you stop dealing with analyses and start applying analytics. More precisely, predictive analytics. Remember that we separate predictive analytics into two branches: traditional methods, which comprises classical statistical methods for forecasting, and machine learning. In this video, we will focus on the first type. Great! So, what are the techniques involved when applying traditional data science methods? Though there are many, a word we often come across is regression. But what do we mean by this? In business and statistics, a regression is a model used for quantifying causal relationships among the different variables included in your analysis. Let's explain this through an example. First, look at this data set. In one column, we have house prices in dollars, while in the other, house sizes measured in square feet. Every row on the data table is an observation, and each can be plotted on this graph as a dot. The house size is measured along the horizontal line and its price on the vertical line. The further to the right an observation is, the larger the house size, and further up, the higher the price. So, once we've plotted all 20 observations from our dataset, our graph will appear like this. Okay. The thing is, there is a straight line called a regression line that goes through these dots while being as close as it can be to all of them simultaneously. Now, imagine we drew another line like this. Do you think the observations altogether are closer to the first red line or the second green one? Yes, they are closer to the red line. This means that it more accurately represents the distribution of the observations. So, without getting too technical in this video, a line like this is associated with a specific mathematical, or as theoreticians would say, econometric expression. In this case, if Y signifies the house price, then B represents a coefficient which we multiply by X, the house size. So, the equation professionals work with is Y equals B times X, and they use the graph as visual support. For now, let's concentrate on the visualization and leave the mathematics for later. Excellent! So, naturally, if there are linear regression models, there must be nonlinear ones as well. True? Correct! A logistic regression is a common example of a nonlinear model. In this case, unlike the house prices example, the values on the vertical line won't be arbitrary integers. They'll be ones or zeros only. Such a model is useful during a decision-making process. Let's elaborate on that. Companies apply logistic regression algorithms to filter job candidates during their screening process. If the algorithm estimates the probability that a prospective candidate will perform well in the company is above 50%, it would predict 1, or a successful application. Otherwise, it will predict 0. Therefore, the nonlinear nature of the logistic regression is nicely summarized by its graph. Very different from the linear regression, right? Okay, great. Are there different types of regressions? Look at this graph, and again, relate it to the house prices example. These observations come from a third dataset. Imagine they are derived from research on German house prices, hence, they are dispersed differently. Sure, we can draw a regression line, but could we do something better? Yes, we could. When the data is divided into a few groups called clusters, you can apply cluster analysis. This is another technique that will take into account that certain observations exhibit similar house sizes and prices. For instance, this cluster of observations denotes small houses, but with a high price. This could be typical for houses in the city center. The second cluster could represent houses that are far from the city because they are quite big, but cost less. Finally, the last cluster concerns houses that are probably not in the city center, but are still in nice neighborhoods. They are big and cost a lot. All right. Noticing that your data can be clustered is important, so you can improve your further analysis. In our example, clustering allowed us to conclude that location is a significant factor when pricing a house. Great! And what about a more complicated study where you consider explanatory variables? Apart from house size, you might have quantified the location, number of rooms, years of construction, and so on. They can all affect house price. Then, when thinking about the mathematical expression corresponding to the regression model, you won't just have one explanatory variable, x. You will have many, x1, x2, x3, and so on. Note that an explanatory variable can also be called a regressor, an independent variable, or a predictor variable. Now, let's move away from the house pricing example. Imagine analyzing a survey that consists of 100 questions. Performing any analysis on 100 different variables is tough. This means you will have variables starting from x1 and going all the way up to x100. The good thing is that often, different questions are measuring the same issue, and this is where factor analysis comes in. Assume your survey contained this question. On a scale from 1 to 5, how much do you agree with the following statements? 1. I like animals. 2. I care about animals. 3. I am against animal cruelty. People are likely to respond consistently to these three questions. That is, whoever marks 5 to the first question does the same for the second and third questions as well. In other words, if you strongly agree with one of these three statements, you won't disagree with the other two, right? Well, with factor analysis, we can combine all the questions into general attitude towards animals. So, instead of 3 variables, we now have 1. In a similar manner, you can reduce the dimensionality of the problem from 100 variables to 10, which can be used for a regression that will deliver a more accurate prediction. Fantastic! To sum up, we can say that clustering is about grouping observations together, and factor analysis is about grouping explanatory variables together. Awesome! Finally, we'd like to show you what time series is. You will use this technique especially if you are working in economics or finance. In these fields, you will have to follow the development of certain values over time, such as stock prices or sales volume. You can associate time series with plotting values against time. Time will always be on the horizontal line, as time is independent of any other variable. Therefore, such a graph can end up depicting a few lines that illustrate the behavior of your stocks over time. So, when you study the visualization, you can spot which stock performed well and which did not. Excellent! We must admit there's a vast variety of methods that professionals can choose from. This was just a brief introduction into the basic types. Keep the pace for the next video. Thank you for watching.